Okay, well, welcome everyone to this meeting of the virtual CICS user group. I'm Trevor Eddles. I'm CEO of iTech Limited. We're a mainframe consultancy analysis and technical authoring organization, and we're the people responsible for the content on the Virtual CICS website. We produce the newsletter, and our website is at virtualcics.hostbridge.com. And if you've got any friends who use IMS, we also look after that. Okay, let's start by running through the agenda for this meeting. As usual, most of the meeting will be taken up with the presentation. And today our guest presenter is Wendell Lovewell, Product Manager and Systems Programmer for MacKinney Systems. And he'll be discussing taking the pain out of CICS application debugging. And a copy of the slides from this presentation will be on the website later today, certainly by tomorrow. And if you missed any of our previous meetings, you can download copies of those presentations from our website too. And you can also listen again to the whole presentation. There's a link on our resources page. So that's virtualcics.hostbridge.com/resources.htm. Following Wendell's presentation and any questions you have for him, we'll move on to the latest CICS news and the latest CICS related articles. Feedback requests is there to remind me to ask you for your feedback about this virtual meeting, and then I'll give you the dates and times for the next couple of virtual meetings. So that's the plan for this meeting. I'm anticipating that it'll last about 50 minutes, something like that. Anyway, as I just said, today's presentation is from Wendell Lovewell. Wendell is a product manager and systems programmer for MacKinney Systems. For more than 40 years, he's been providing product support for CICS, ISPF, and batch products, and systems programming support for ZOS, ZVSE, ZVM, Windows Server, and Linux. His favorite programming languages, he says, include Rex, COBOL, and Assembler. So, Wendell, I'd like to thank you very much for being with us today. And what I'm going to do now is pass control over the meeting to you. So let me stop sharing my screen, and you should be able to start sharing yours.
All right. Can you see that, Trevor?
Yes, I can. Yes.
Okay, good. Hey, everybody. Thanks for being here today. I'm going to talk today about ways to make your life easier. Generally speaking, the better you are at something, the easier life is, or at least easier your work is. So we're going to kind of start by trying to be a better programmer. But I guess that begs the question, what makes a good programmer? I like Larry Wall's description of 3 qualities of a good programmer. The first one's laziness. You go to great lengths to reduce overall energy expenditure. Now, these are actually, I got these directly from the Pearl Doc glossary. So you'll work hard to not have to work hard. I'm a script junkie, and I will script something rather than do it 5 times, do the same thing 5 times. Another attribute is impatience, and you get angry waiting for the computer to do what it needs to do. And the third quality is hubris, which is a little unusual, but in his definition, it's excessive pride that makes you want to do basically a good job so others won't be critical of you. So let's talk about laziness first. How do you be a better programmer? You let the computer do it for you. I see people doing repetitive things over and over again, and it's like, why don't you let the computer do that for you? So you look for opportunities for letting the computer do things, because it hurts to do things slowly. My title is Taking the Pain Out of Application Debugging. And so the things that it hurts are your productivity, your time, how long it takes you to get something done, and your esteem from the people you work with and your boss. So this is my attempt to humor, and I'm going to date myself and show my lack of sophistication. But there used to be a program on television here in the States called Hee Haw. And Hee Haw was a bunch of skits, and they were really corny. And one of the skits, this doctor, here he is in his office, this doctor would see patients, and the patients would come in and say, well, doc, it hurts when I do this. And you can see what kind of gyrations he's going through. And the doc would invariably say, then don't do that. So what is it we do that hurts when we do it, that we can maybe get out of a little bit? Is it reading dumps? Is it looking at traces? Is it stepping through debuggers? What's really the time consumer in your diagnostic process? So let's look at dumps first. I kind of base this talk for an introductory type audience because if you've been around a while, this is all going to be obvious. But I promise if you hang with me, I'll show you something you don't know. A transaction tab bending is probably one of the more common indicators of something going wrong. It depends on the system setting, but something called a dump can be created. Maybe not, maybe. And a dump contains the contents of memory used by a program and some indication of what instruction the program was executing when it had a problem. So if the user gets an error or an app bend, they get a message on their terminal, 3270 terminal at least, saying, okay, the transaction failed, here's the problem, and don't worry, we backed it out. Maybe there's a dump on a message on the console where it says, okay, this program app bended, and that's serious enough that it generated this kind of app bend, but we didn't really take a dump for you this time. Another indication of dumps is messages go into one of the message user transient data destinations. Message user is a sysout, usually destination defined in CICS for writing messages. And there are dozens of different transient data destinations that are designed for messages. Sometimes you may have a product that aggregates those, like our CSS log view here. You may have just go to the sysout for the started task and look at message user DD to see what messages are generated there. But that's a really common place for problem indications to turn up. So let's pretend there was a problem and it did produce a dump. Well, maybe it produced a dump. What do you have to know? It depends. The first thing you have to know to read a dump is, well, where did it go? Where is it? And that also depends because you have to know what kind of dump, if there was one, and you have to know where it went. So there's two kinds of dumps. There's a transaction dump, which just contains the memory used by a particular task, usually program, that has the program variables, the working storage if you're a COBOL person, the procedure division instructions, of course, turn into a similar machine code. And if there was a transaction dump, message user is a good place to see those messages. In this case, it generated one to CDUL, and then it also generated one to CSMT. CSMT is probably the most common transient data destination for messages. We use that here ourselves a lot. There's also system dump. And a system dump contains, whereas the transaction contained the program, the system dump, you guessed it, contains the system, which can be really big nowadays. I mean, we can have gigabyte region sizes, and it can take a long time to dump out something that big, write it to memory so it's preserved, or write it to a disk so it's preserved. So it's common that the dump be suppressed unless you really, CSS assumes you probably don't want very many of them at least. And we'll look at that in a little bit. But back to transaction dumps, you need to know, again, where it went. because there are two dump data sets. It could have gone to DFH DMP-A, or it could have gone to DFH DMP-B. Those two dump data sets flip-flop. They're both defined. They're always defined in CICS region, JCL. Only one of them can be active at a time. And you do a set dump switch using the CEMT command to control which dump data set is active. If the first one fills up, it will switch to the second one, I believe, but I don't know that it'll switch to the other one. I'm sorry. So the set dump switch command shows you which dump data set is currently open. And here it's saying, well, I'll go ahead and switch with the automatic indicator. So yeah, at a minimum, you have to know dump A, dump B. And then you also have to know JCL to print the dump. Each release of CICS has its own version of the dump printing program, DFHDU, and then a 3-character release number. 730 happens to be for TS 5.6. 720 was for TS 5.5, and so on. So the dump program is located in the SDFH load library for that release of CICS. You have to tell it which dump data set. The DD is always the same, but you change the data set name to control which one you're printing. And then you may also use the selection criteria in the SysN to so that you only get the dump for the transaction you care about. There may be multiples out there. If you don't specify a tran ID or a term ID or something, you end up printing them all, which is unwieldy. Here's this link at the bottom. If you download the PDF, this link shows you the formats of the SysN data. You can select the type and lots of stuff I'm not going to go into today. So you got you know where the dump is, you got the JCL to print it, and you print it, and then what? Well, it turns out that's the easy part. The difficult part is really what you do with it. How do we call it read a dump. And it turns out that you have to know a lot to be able to read a dump. If you get a listing back, it'll start something like this, and it's going to have the program status word, which is some settings, and then turns out to be the next instruction that would have been executed at the time of failure, not the one that did. This is, you're going to be shown the registers, which, since this example is in a similar program, it's really very easy to relate back to what's going on using the registers. In my case, I know that the Reg 3 is the base register, so the program started at this address. It failed at the instruction for that address, so if you subtract this from that, you get hex 186. Okay, that's fine. What about that? Well, somewhere down in the listing, in this case, transaction listings are pretty small. I mean, depending on the size of the program. Still 2,800 lines later, you get to the program storage, which is what those addresses relate to. They don't tell you the actual addresses, they're just program offsets. And 1A6 is actually, or 186 is actually in here somewhere. And it's like, well, why doesn't that show up with what I know? Since I made the admin, what I know is wrong. And the answer is this storage up here, there are 28 or hex 28 bytes of stuff that goes into the load module that doesn't get executed because the program starts right here at this store multiple where I'm saving the registers 14 through 12. So you have to add 28 to that address, and that does come up with 1AE, and 1AE is actually this 47 Fox 0, the branch unconditional. And like I said, that's the next instructions that would have been executed. So You back up one, and this happens to be a 2-byte instruction. It's a divide register 0 by 5. So you can also match up in your program listing word offset 1AE, but doesn't count the first 28 bytes. If you have the program listing, which you really need for a dump, you can go to that and see that 1dog05 is this divide register 0 by 5. And since I made it abin here, I cleared out reg 5 and divided by 0. And so I got the divide by 0 exception. Let's go on to system dumps. Now, the thing about system dumps is the CICS regions can be really big, and that means that it takes a lot of memory, a lot of storage, a lot of time to create a system dump, relatively speaking, a lot of time. It's resource intensive, and it's something you don't want to do unless you really need to. So very frequently you'll see if you get a dump that the system dump was suppressed by the dump table because CICS has decided you really probably don't want that. You can control how that works. You can set system dump on, and you can, with the CEMT set side dump code command. Now, these are specific to the type of add-in that you have experienced. So if you have a problem and your values aren't set so that it will take, you're going to have to recreate it. But on the other hand, if the values are set so that the dump will be created and you don't really want it, it's expensive. So set side dump, you specify the add-in code, and this sysdump or no sysdump is the option here. You can turn it off completely with no sysdump. If it's on, it still might not take a dump depending on how many times it's already done that. The current value is how many times CICS has already created that kind of add-in in this run of the region. You can see here this add-in's already happened twice, and the maximum is how many dumps CICS will take. So your maximum has to be higher than the current value before it will take a dump, even if sysdump is on. So in this case, it was 2. I set it to 3, press enter, now it's 3, and I can recreate my problem, and there are my dump messages on the console. You can see it's the same add-in. It tells you what kind of add-in. This is actually a different add-in. But it tells you that the dump was started. If we had the timestamps over here, you could see how many seconds elapsed between started and ended. Here it tells you it's complete, the return code 0, and this is the important part here, the data set name where the dump was written. ZOS controls a lot of the dump process, and one of those is you tell it in ParmLive how to name the dump data sets and what volumes they go on. And it's up to you to keep the volume clean enough to capture them, because you can also request to see a system dump and then not have enough room for it because they are so big. But this one went to sys1.svc dump. This is actually the system name and the date and the time and the type of dump. So what do you have to know about system dumps? Well, how they work, and then that they're big. But the main thing to know about CICS dumps is, like our hee-haw doctor said, don't do that. You may ask for one, or your IBM may ask for one, or a vendor may ask for one, or you may just be, have your doctorate in CICS internals, like I do not, and be able to handle those. And I know a lot of you on the who are listening can do that. There's a lot of experience here. But there again, first timers or introductory kind of CSS application programmers, it's like you really probably don't want to go in here unless you just absolutely have to. But you may be asked by IBM or a vendor like us to send one. Sometimes that's just what it takes. And, people like vendors like us, like IBM, have people who know what to do with it and they're very comfortable there. And yeah, it takes some time, but they know what they're looking for. And it may be in, sometimes it's only the only way they can resolve an issue. So that's one of the advantages of a dump is sometimes you just have to. Other advantages are it's free. You don't have to have a special product. Even IPCS is included with the ZOS. So it doesn't cost any more except your time and your required expertise. And also, it's already set up for you. The system programmer would have allocated the dump data sets in the JCL or provided space for that for a system dump. So you don't have to, as an application program, you don't have to do anything to get one. But that's not all roses. It's usually really labor intensive to read one. I remember when the first dump that I got when I was hired as an application programmer, the language is PO1, and I mean, it seemed to take forever to track down all the and this is on paper too. Take forever to track down all the addresses and the control blocks and find out the value of the variables in that procedure. And honestly, I thought it was crazy. It's like there's got to be a better way to do that than this. And pretty much since then, I've written my own trace records. Display messages of some sort or another. You might have heard of Log4j recently. That's a way for Java people to write their own log messages. Yeah, you have to know a lot to use them, and you only get a picture of what happened that instant. Sometimes it's hard to tell what led up to that. There are some trace tables usually recorded at the end of the dump that will help. But then again, you have to know traces. So how do you use the CICS trace? There's an integrated facility. Every CICS has it. It's sorry, losing my place here. Every CICS has it built in. There are two types of traces that CICS is using. And remember, traces are used by Hersley to diagnose CICS itself. So there's lots and lots of information, and the internal tends to fill up and wrap. When it gets to the end, it'll start at the beginning, and there's a pointer that tells you where the current one is. There are two external traces files. External trace is usually called oxtrace, and there's a DFH oxt, and then I guess they decided they needed to flip-flop them, but they like the word ox. So unlike dump A and dump B, it's DFH-AUXT and DFH-BUXT. Okay, so you turn oxtrace on by using the CETR transaction. If you just go into it, you can probably see the same thing I'm looking at, although your trace table may be bigger, maybe should be bigger. That's only 4 bag. These are all above the bar in the later releases of CICS, so you can have a lot of storage tied up that way. Usually the trace trace status is going to be stopped, and this will show you, okay, the one we will use the next time someone starts it is the ox-A or ox-T. There's BUXT also. And this is going to say, well, when A fills up, go ahead with B if you specify next, and so on. Now, like I said, it records a lot of information. So it may be that you want to press PF5 there for the terminal tran, and specify the transaction that you want to record. UC trans on here, so this is going to be converted to capital KASE. I probably should have done that to start with. So you can tell it I only want the application or the transaction that I'm trying to debug. So you to start it, you okay. Trevor, can you hear me?
Yeah, sorry, I think that was me. I was clicking on something else, but I think it was muted you. So my
Okay.
apologies. Sorry.
Yeah, no, I saw the message. I could have done something wrong easily. Okay, so you type in started and you press enter, and then you run your test, and then as soon as you can, you get back to CETR and you stop it because you don't want any more going into that data set than is absolutely necessary. So then, like the dump, you've got your tracing on the disk, but you need to do human readable kind of interpretation. And there's, like the dump, a DFH instead of DU for dumps, it's TU for trace, and the release number. It's located in the same place, the SDFH load. I can't remember what's in link. And you do, like the dump, have to specify which trace data set you want to print from. And whereas the other one had sysin, I think this one has OXPARMs. And you specify in the sysin the kinds, you tell trace program or trace format or what you want. Here I'm saying I want the whole data set or whole trace. I don't really, I'm turning off page headings here because they get in the way when you're on a terminal. And I just want my transaction. There are lots of different things you can select by term ID, task ID, time. You can get full, you can get just part of it, you can get abbreviated. There are lots of things you can specify, and like the dump, here's a link for trace that shows you those sysin parms. So you print them off, and then like the dump, you got to know what you're doing. And this is the slow part. For everything that CICS does for you, for your transaction, two entries are recorded, at least two. There's an entry when I entered this function locate in this case, and then there's an exit timestamp is over here. These are nanoseconds, so a billionth of a second here, and you can subtract that from this to see how many billionths of a second that function took. But the thing is, it's like looking for a needle in a really big haystack. You can maybe with your editor, you can look around. If you know IPCS, this is a good place for that. But you're looking around to see what went wrong. And the thing is about looking at a picture of what happened is if you're not familiar with what normally happens, you can get really hung up on, is this supposed to happen? And it's really like you not being able to see the forest for the trees. So, well, like I said, even my little 65 statement program, it only had 5 exec CICS statements in it, and not all of those were executed. It still generated around 1,600 trace entries. Now that's an entry and exit pair, like those two there. And the print was nearly 20,000 lines of print lines just for my little bitty program. So you see how easy it would be to get lost in there. And even if you can find your way, maybe just search for Azra and say, oh, that's there, and that's our exceptions. Turns out there are a lot of exceptions normally. I did learn something about LLA copy while I was in here. Okay, so it's not a really easy place to be. There are products that will help you format those. I know Ezra Gross is a frequent speaker, and he's got a product that formats a trace. IPCS will format a trace and help you decipher it. But like I said, if you don't know what's supposed to happen, it's hard to see what went wrong. Also, I did mention that DFHDU release number will include abbreviated trace table at the end of that. Okay, so what are the advantages of using Octrace? It's like CICS or like dump. It's free, comes with it, with training. IPCS, which is also free, although the training's not, or the time you take to learn it is not. Trace is always there, no problem, no prior setup needed. You're probably not going to be running external trace all the time, so you probably have to have a problem that you can recreate before this will do any good. But sometimes it's just what it takes. And usually, again, you send them to IBM or a vendor and not something you really want to do with them. The disadvantage is you just really have to know a lot to be able to use them. I kind of think of it as having a doctorate in CICS internals. Like I said, there's a lot of data generated. My 5exec CICS program generated 20,000. Can you imagine what a 8,000 line program would do? You may have trouble capturing trace records for that big a program without a large stump data set or trace data set. And like I said, can't find the forest for the trees. There's so many details that it's like, what is it I really supposed to be looking for? So need to move along here. Debuggers. There's the third type of application diagnosis is known as a debugger. And a debugger is an add-on product. You have to buy it. IBM doesn't include it with CSS or COS. And basically a debugger lets you see your program execute. You can look at the statements that are executing. You can look at variables, the value of data. You can control. You can change that data. You can control the flow of the program. You can do some really nice stuff in debuggers, and well, they're great. They work by looking at the machine code that's about to execute in your task, like that Fox 7 or 47 Fox 0, and they know, oh, that should be here in the listing, and they match up the executable code that's in CICS with an assembler listing. So at some point, you have to set your program up to do that, because if the debugger doesn't have your listing or access to some compiled or assembler data like AData for some of them, it can't tell you what the program code that or the statement that you coded is. So you often will have a post-processor step to a compiler that says run it through the debugger preprocessor, so that if I have a problem, I can debug it without having to do anything else. One thing you need to realize that debuggers are real time. You can't have a problem the night before and go back and look at it with the debugger unless you can reproduce the problem. You have to tell the debugger, okay, I want to debug this program, and they've all got different ways of doing that. And some of them are hard, some of them not. And the user interface for the debugger is, well, the ones that have been around a while all have had a 3270 interface. I don't know of one that doesn't. Some of them have web browsers. Debug tool from IBM does. Here's an example of our debugger. We call it Track. It shows me in this program, which I had to tell it I want to see that program, and it noticed that it was about to be executed when I typed in the KASE command, or transaction ID, and it stopped it here, and stopped it at the first statement, executable statement. You can change wherever you want it to stop. In ours, you scroll down, and if on my screen, if it's blue, it's input allowed, and I type a halt command or a continue or whatever. You can see in my case, it's working with variables. This is a similar program, so it's showed me all the assembler or all the registers. And you can go through it, decide, I want to stop here, I don't want to stop here. If you step through every statement in a program, it's going to take you a really long time. So what you can do is you set halt points where in the execution of the product, you say, I want to stop here. So I did. I pressed the PF key that said run until you get to something you have to stop for, and it stopped here. Here it's showing me I'm moving a constant full word of 450 into a variable. You can, if you know the assembler, the machine instructions, you see that the instruction length, the data length is 3, which means 4 in assembler. So this is a full word, and this is a full word also. And I'm about to move a binary 1C, 1 Charlie 2, which is a decimal 450, into the storage at this address in the program. Here I've also kept a variable that I say I want to see this every time. At this point, it doesn't have anything in it, and so then I go on and I tell it to not stop until something else happens, like a halt point, or in this case, an error, an admin occurred. We can see that this line is highlighted. It's a divide register 0 by reg 5, and it's like, I wonder what is in reg 5, and it's like, oh, it shows me here and it's 0. So yeah, I'm going to get a fixed point divide. It tells me what kind. And, in this case, simplest case you'll ever see, I did it on purpose, subtracted reg 5 from reg 5 and made sure it was 0 so it would blow up. Here's that value that I kept on the screen all the time, and it's still set at 450. Okay, so debuggers are great, but what are the advantages? You can see your program executing. You get a visual representation of the program statements that you coded doing what you think they're going to do. You can change some of the data, test on the fly, exceptions. Maybe your editing program is rock solid. So you introduce some data that way. You can verify results. You can, like I said, you can see every statement. And the biggest advantage, other than actually being able to see your program, is that it's easy. If you can code, you can understand what the debugger's telling you. You don't have to know CICS internals. You don't have to know IPCS. It's just intuitive and easy. But there are some disadvantages. We started off wanting to make our life easier by letting the computer do a lot of the work, and the computer's still doing a lot of work each statement here, but you can take a long time to step through every line in a program. Sometimes, not often, but sometimes timing is an issue, and you can't recreate a timing problem when you've got the program held up on each statement. And the other disadvantage is you had to be there. It's not something you can crank up and say, oh, show me what went wrong with the admin last night. If you can recreate it, that's great, but otherwise, this is not the tool for that. So, so far we've learned reading a dump is not only, it sure is hard, but at least it's slow. Reading a trace is really, really hard, and it's really slow. And stepping through a debugger is easy, but it can be really slow too. So, is there a better way? Well, you probably guessed it. What if you could combine the ability to capture everything that happened like a trace, the ability to display contents of any and all variables like a dump, and the ability to step through every line of code like a debugger, but not have to wait for it? What we'd like to introduce today is a new paradigm, actually, for program development. We've called CICS Task Recorder. I'm going to call it CTR for abbreviated time's sake. But with CTR, you can examine the flow of CICS tasks like a debugger, but you don't have to step through each of the programs. You just go to the part you care about. You can display the contents of selected or all working storage variables. Not not like a dump in that it was a one-time picture, but at each step, and I'll explain what a step is in a minute. Each time there's an event that the CTR records, you can see those at that time. So you've got a moving picture anywhere through the execution of the program. One of the great things save you a lot of time is what's the difference between that and that. That and that being COM areas or vSIM records or DB2 tables. Sorry, not tables, results. And or also the execution of a transaction. It worked this way this time. It worked that way that time. What's the difference? And one of the things, like a tuning product, you can see where it's spending the time. So if you got a slow transaction, run it through CTR and say, oh, it's all on that. And then you go look at where it pointed out that was the slow part. Okay, paradigm's a big word, and do we really deserve it? Well, I think so. It's just different than everything you've done before. It's easy to use. The information is displayed like a programmer. It's point and click. There's a 3270 interface. There's a web interface. You can do what you want. The web interface is a WebSphere Liberty application. It's got some really nice features. It's like a dump, but it's going to format the data into the variable names that you specified, so you don't have to say, oh, that hex 1 Charlie 2 is really 450. It's like a debugger, but you don't have to step one step at a time, and it's like a tuning product. You can observe delays, so it's easy to use. It provides more information. The elapsed time is something that you can get through from the trace by doing math on those nanosecond numbers that it gives. But you have to know, well, which of those entries and exit are really involved here. And you have to kind of guess what happened in between. TCB switches are inefficient and tried to be avoided, and it'll highlight those. You can capture data between mirrored transactions in other regions. So if you're using MRO and transaction A in system 1 starts transaction B in system 2, you can capture the data for both of those and see how they interplayed. Are there delays in one because it's waiting for the other? It formats the data into native language variables and structures like you're familiar with as a coder. And it provides an easy way to compare results before and after code changes. You can run capture a transaction, you can make a change, you capture it again, look side by side and see what the differences were. You can also, this is kind of a big deal. It really helps you understand legacy systems, and legacy being something actually that's older than your experience with it in this case. I'm actually talking to a guy tomorrow because he inherited one of my products at a customer site, and it's like, gee, I don't know anything about this. Can you help me? So he doesn't need to know how the internals work, but as a programmer who's inherited, if you will, a new system, then yeah, it's really handy for just seeing what's going on. You can see which programs are invoked. You can see which files they use or DB tables they use. You can say, just show me the resources that access this vSIM file or this program or this DB2 table. You can compare the data changes to data before and after program calls, so you don't have to step through the program to look to see what it did. You can just if you're branching to someone with a COM area and you're branching back with the COM area updated, you can see immediately what did the program do. Okay, so we've got this great product. How do you use it? And it's super simple. You submit a recording session, you run the transactions, and your results, right? Just like submit a deck of cards and run them and view the printout forever ago. Okay, so this is the 3270 interface to submit a session. Okay, we call them sessions, recording sessions. And you can specify the tran IDs, which transactions you want to record. You can specify all transactions, but only by this user or only at that terminal ID, or you specify how many seconds you want the session to run. And this time when the session's running is actually the only time that the exits are enabled. If there aren't any sessions recording, the exit will disable itself, and you don't have the performance hit on the system of running exits that everybody has to go through, even though nobody's using. So you set a time limit. You can also set, well, I don't care how many, if it hasn't reached 300 seconds, but it has recorded, 300 tasks, then I want to stop. You can just choose which of the data on the different kind of calls are recorded. Okay, I'm lazy. I just type Y next to everything. That's resource intensive, and sometimes it's better to not have a lot of data you don't need. The options here. And you can, if you're having a performance problem, you can throw out, you can say, oh, I only want transactions if they ran over whatever numbers, milliseconds. Now this is milliseconds here. The trace was nanoseconds. These are thousandths. The trace is billionths. And the elapsed time is reported on the screens I'll show in a minute as microseconds. You can also say that I'm recording the session to test this or whatever kind of, it's not very long, 32 bytes, I think. But you can record, you can put a note on the session, and you also specify which regions, if these two are the two regions that are connected via MRO, or maybe there's 3 or 5 or whatever, which region are you going to want to trace? And in this case, I just want the one I'm in. So I just said Y there and left that no. The GUI, the Liberty application, looks like a Liberty application, of course, but the information's pretty much the same here. These are the Y flags. Yes, I want that. Yes, I want that, and so on. Here's where we had the regions. The difference that the GUI adds is that you can specify, okay, in program XYZ, I want to record this and this and this variable, or I want to record the whole working storage, which, as you can guess, might be resource intensive and might be something you don't want to do every time. But you fill out the parameters and you say begin recording. And then you go off and run your transactions or do the things you wanted to record. And as you're doing that, this session is running. At the point of this time, I started it at 1340, and it's going to run until 1345. That's that 300 seconds. I've gone 117 seconds so far, and so far I've recorded 17 transactions that started and ended. And here's some information about what I'm recording and which program and so on. During this time or after, you can click on the tasks button, and you can see the different transactions that were run during that were recorded during that session. In this case, I'm working on a ESI application. Started with ESI-A, and then I did an ESIS and other things. So if you want to see what a particular transaction did, like this one, you can click the summary. And for this task, here's an overview, a summary of what all the transactions were. You can see this one spent most of his time deleting records. I did it 42 times, and the next highest time was also 42 records. I misspoke. The delay here, which is built in, I mean, that's an intentional part of this program. It elapsed, I don't know if I can do the math, 5 seconds, which was 71% of the time that it was, the session was recorded. And you can see, okay, I got a not found there, link there. You can see the resource that it was working with. This is a vSAN file. These are temp storage queues. And you can see the elapsed time in microseconds again, and how many times it was run. So this is the summary. This is not the step-by-step thing. So if you clicked on task, you would see the step-by-step part. And okay, a step to CTR is an event actually that gets recorded. In this case, the first thing, this brown, is CICS. CICS did a get main for the program before it started. Support it's working storage, right? Then the first thing that it recorded for in the program itself, which is this name, at this offset in the program, was it ran this procedure. Now the procedure is not natively something that can be recorded, but there is a preprocessor in CTR where you can say, go ahead and insert some statements. It's going to make my program bigger, but I need to debug it. Insert these statements so I can see which paragraphs were running. Here you see the elapsed microseconds and a running total of how long the transaction ran. So we're looking at, what is that, 0.005 seconds. If you click on the buttons here on the left, let you display data in the program, a COM area right here when it X control to a different program, a working storage. You can, since this is a program we recorded the whole working storage for, you can click that and scroll through it. That's can be a lot of information, so you can click the delta on the working storage and see what changed since that call. That's real handy. Here's the working storage. I'm scrolling through that a little bit. Nothing too informative there for us. And here here's a display of clicking the COM area, and it will show it to you in character. You can click that and display hex. You can click this and display the mapping, which is what I've done here, and it shows you the COM area formatted into the variables that was used in the program itself. Here's an example of an SQL program making calls, and you can click. I have already clicked this and this button, so you can select these things from this table, so you can see what the select statement was done, and you can click on the values, and have it formatted into the values returned from the SQL statement. So like when I ran this select, I got Mustafa Cohen as the name. You can expand to and compare the difference between this result set and this result. So if we click the diff buttons, it will display the differences. It turns out that Blue Horse McNeil and Mustafa Cohen don't have anything in common except they're both males. Okay, but the turquoise is differences, the white's the same. And you can do that with vSAN records and COM areas and working storage variables in the same session or different sessions. here's an example of, I'm sorry, I am out of time. 3 sessions being merged together, and here is the one transaction, here's the other transaction, here's the third transaction. These were all in the same region running at the same time, but they could be also in different regions. So you could see the interplay between the regions. So, gee, Trevor, I misled you. I've got 4 minutes left for questions.
Yeah, if anyone has got any questions, then if they can just type them into the chat, please, and I'll read them out for Wendell. And I'll give you a couple of minutes to think about what we've been told. All right, Hugh Mayfield says, no questions really, but looks incredible. Hope to have a chance to try it out.
Well, thank you for your time, Trevor. Or everybody's time.
Let's see if anyone else has got anything to say.
Just one quick question. Will this video be available or shared with the participants?
The session will be recorded, so you'll be able to access it from our website. So from virtual CICS.hostbridge.com. That'll be there later tonight or tomorrow morning, depending which time zone you're in.
That's great. Thank you.
Okay, Steve Bow says, do you see this as a development tool or something that could be used to troubleshoot in production environments? And then he said, probably depends on overhead.
Well, yeah, I mean, it depends on what you're looking for. If you got a problem in production and it's a particular transaction, let's say it's taking too long, you could turn on a recording session and say, I only want this transaction and I only want it when it runs over, this many thousand milliseconds or whatever. Generally speaking, it's more probably of a development tool because even though you're not there affecting the region, the program running, I'm sorry, I didn't take time to or save time to run an example. Even though it doesn't interfere with the running of the program, the exit is getting invoked, and there's some amount of overtime. It's probably immeasurable, but there's some amount of overhead that would be accrued with the exit being active for every single transaction that you ran on that system. So it's like everything else, Steve. It depends.
Okay, John McGee says, my guess is that a lot of storage would be required to contain all of this CTR data.
Yeah, I mean, if you go crazy and record all the working storage for big programs, and you do a lot, it's actually stored in a vsim file. Most of us know, the restrictions and the things. There is a cleanup utility that you can run. There's a built-in expiration that you can set so that you can clean those things out. But yeah, you'll probably want a big, we call it the CTR file.
Okay, yes. So Ishibiran's saying that after you finished examining the recorded info, you can delete it.
Right.
Yeah. So anyone else got anything? No, well, looking at the time, I'll move on. So I'll say, Wendell, thank you very much for that presentation. That was really interesting, and interesting to see the new product. So as usual then, can you assume that we're, being a virtual user group, we're giving you a virtual round of applause. So thank you very much for that session.
I'll virtually accept that. Thank you.
Thanks. Right, if you can stop sharing your screen, then I'll go back to sharing mine, and I'll rush through my bit. Okay, here we are. Yeah, no, thanks a lot. And just to say, if anyone does have any more questions for Wendell, you can email me and I'll pass them on to him. So we make sure that no questions go unanswered. Okay, let's Right. We've got some news. This time IntelliMagic has announced that IntelliMagic Vision for ZOS release 10.9.0 now includes major enhancements to reporting on CICS SMF data that lets users monitor the performance and resource usage of applications and transactions. New functionality includes support for 19 fields in the statistics data and more than 70 automated health insights for the CICS 110 SMF data. And there's, excuse me, a link to that news story on our website. As for articles and blogs, we've got CICS VR executing batch backout when the RCDSs are unavailable. That's by Dion A. Narissa in the CICS part of the IBM Z and Linux One community. Oh, sorry. We've got seamless vSAM data transfer between host and PC by Dion A. Narissa again in the CICS part of the IBM Z and Linux One community. And we've got CICS VR change accumulation by Chitra Devi S in the CICS part of the IBM Z and Linux One community. Oh, excuse me. And again, links to all these articles and blogs are on our website. There's my email address if you need to contact me with a question or any comments about this session, if you've got any feedback about the meeting. And as you can see, plan for the future. 8th of March, we've got Joe Winchester from CICS Hersley. He's going to be talking about CICS and open source tooling with a focus on Zoe. And then 10th of May, we've got Robert Barnes, CEO of Jazz Software. He'll be discussing CICS web services, bridging two worlds. Right, the Arcati mainframe yearbook. I know some people filled in the survey. The 2022 edition will be available either at the very end of this week or the very beginning of next week. It's completely free. It's available as a PDF. You can download it. It's got sections on, well, the user survey, a directory of vendors and consultants, a resources guide, a strategy section with papers on mainframe trends and directions, a glossary of terminology, and a mainframe evolution section. So look out for that. And yes, you can keep up to date with what's going on with the virtual CICS user group and the world of CICS by following us on Facebook, Twitter, and LinkedIn. If you do use hashtags, then if you're talking about us, we're hashtag virtual CICS. Oh, and of course, we like likes. So if you are on Facebook or whatever, like our page. So that's all for this meeting of the virtual CICS user group. Can I thank you all for attending? Thanks to Hostbridge Technology and Rocket Software for sponsoring our user group. And of course, I'd particularly like to thank Wendell Lovewell for his presentation. So that's it. Thank you all very much for joining the meeting and hope to see you again on the 8th of March. So thanks and goodbye.